Alright, this is Mr. Holsey of A Squared Sufficiently Understood Science, and today we're going to be looking at eclipses and tides. So we're going to start off by talking about lunar eclipses. So a total lunar eclipse is when the moon is entirely inside the Earth's umbra. So the umbra is its shadow. Okay, and so I'm going to draw a little diagram right here. So we have the Earth and the sun. Of course, this is not to scale. And so the moon will be at the full moon position, so directly behind the Earth. Ooh, that is not a very good, not a very round moon. There we go, close, much better. And so in this situation, the shadow of the Earth is directly over the moon. And so this is going to create a moon. We still actually will see it during a lunar eclipse. It'll get dark. So it'll get dark as the Earth's shadow goes over it. So I'll show you kind of what it does here. So I'm going to color this in so I can kind of work on it. So anyway, so as the Earth goes over it, it will kind of darken out a little bit, and then you'll start seeing it, kind of start turning this orangish color as it goes. And you may have heard of this. This is called a harvest moon. Till eventually we have a fully orange moon, like you saw on the title card. And so this is a total lunar eclipse where the entire moon is inside the Earth's shadow. Now, we also have a partial lunar eclipse, which is an incomplete lineup, where part of the moon is inside the Earth's umbra or shadow. But then we also have a penumbral lunar eclipse. And this actually happens all the time, because the Earth doesn't just have a shadow directly behind it, it also has a shadow like this. And so this is where the moon ends up in this area, or this area right here, not directly in the shadow, but it does have enough, light blocking to decrease the brightness of the moon by about 10 to 20%. But that isn't really that big. And so penumbral lunar eclipses actually happen really often, as opposed to total lunar eclipses, which happen a few times a year. So for a lunar eclipse to happen, the sun, earth, and moon must align. Now, we already talked about how that's a bit difficult because the moon is on a 5-degree orbital tilt. And so it only happens during certain times of year and when things are lined up just perfectly. And so the Earth casts a shadow, or umbra and penumbra. So the umbra is the most direct shadow, while the penumbra kind of fans out to the side across the moon as it orbits into the Sun-Earth path. So then the moon will darken and may become red like smog or a sunset, because it's illuminated with light scattered not directly by the sun, but now by the scattered by the Earth's atmosphere. And so we end up with some really stunning images to look at. So this is a total lunar eclipse. And it's absolutely breathtaking. You may hear this sometimes called a harvest moon, or a blood moon. So there are also different types of solar eclipses. And so the lunar eclipse occurred when the moon was at a full moon, but a solar eclipse will occur when the moon is at a new moon. So a total solar eclipse is when the moon completely obscures the sun for an observer at this location on the Earth. And so if we draw our Earth right here and we draw our sun, okay, the moon will be between the Earth and the sun, and it will be putting a shadow directly on some point on the Earth. And so the sun, it's really kind of crazy just how perfectly lined up we are, because the sun, the moon, and the Earth are just the right different distances away that the moon perfectly blocks out the sun. And so a total solar eclipse obscures the sun completely. That's when we can see the corona and solar winds and things like that. Now, a partial solar eclipse, where the moon partially obscures the sun for an observer, is more common. The total solar eclipse doesn't happen very often. Then you have an annular solar eclipse. So the moon is near apogee and its angular diameter is insufficient to completely cover the sun. So it's actually further away, and so it's not quite big enough to cover the sun. So an observer for whom the moon and sun are aligned would see a ring of the sun around the moon. So total solar eclipse, it gets dark. Partial solar eclipse, part of the sun is blocked out by the moon, and in an annular solar eclipse, it is covering the sun. The moon's directly in front of the sun, but it's at its furthest point in its orbit to where there's still like sun around it. So it would kind of be like, to give you an idea, like annular. Be like, all right, so I got the sun here, and so the moon would block out like most of it, but you'd still see like the sun in the background a little bit. Anyway. So a total solar eclipse happens when the sun and moon align. Okay? And so the moon's going to cast a shadow on part of the Earth as it orbits into the sun's alignment. And make sure you guys never observe a solar eclipse with your naked eyes. Always wear glasses because it can damage your eyes. So this is the moon's shadows on Earth. You can see it actually casting a shadow there. And this is actually the 2017 one. So this was actually taken by a friend of mine who time-lapsed it. So you can see the moon moving in front of the sun, okay, as it goes. Then all the way down here, we have our total solar eclipse. And you can see we start here. We have just a regular sun. You can see the moon moving right in front of it as we go along. And as it gets closer and closer to totality, we can see the solar winds, also known as the corona. This is the only time we can see the corona without specialized telescopes. And this is just absolutely gorgeous. I love this picture. I'm so happy she took it for me. And so right here we have, we can see all those solar winds in a lot of detail. And these are always there. It's just we can't normally see it. What I'm very impressed with here, if you look at it, I mean, it is just a perfect fit between our moon and the sun. It's kind of crazy how that math and geometry works out for our planet. And so, because we can map the rotation and the 5-degree orbit of the moon, we can figure out where solar eclipses, total eclipses, are going to be throughout the entire year. So right here, we're looking at total solar eclipses. And so these blue lines represent areas where you'll be able to see a total solar eclipse. And so this is actually several years old, but here is the one that we observed in the United States last year. And so here will be our next one that we'll observe here in the United States. And so that's actually going to come through Texas, which is actually kind of cool. So let's discuss tides. Tides are caused by the interaction between gravity and the Earth, Sun, and Moon. And so these tides are going to affect our water levels. And so Most coastal areas experience 2 low tides and 2 high tides every lunar day, approximately every 24 hours and 50 minutes. And it's affected by the moon's gravitational pull. So on the side where the moon is, we experience high tide. So when the moon is pulling right here, and it's lined up with the sun, we get high tide. Okay? On the side where the moon's not lined up, we get low tide. So why are there 2 bulges on here? Because it could be where the moon or the sun is back here, right? And they're pulling in the same direction. And so the answer is inertia. The gravitational attraction between the Earth and the moon is strongest on the side facing the moon, causing the water on the near side to be pulled towards it. Inertia tries to keep the water in place on the near side, but is overpowered by the pull of gravity. So on the far side, the pull of gravity is less because everything's further away. So inertia is able to overcome the gravitational force, and the water tries to keep going in a straight line, moving away from the Earth, forming the bulge or the high tide. Now there are 2 tides that we need to understand. That is the spring tide and the neap tide. So spring tide is going to occur twice a month, and that's when, first off, when we are at a full moon. So when the sun, the earth, and the moon are all aligned like this. Okay? So the stronger gravitational pull of the sun is pulling the water towards it, and the weaker gravitational pull of the moon, but because it's closer, is causing it to go over here. So the tides will be higher in a spring tide than in a neap tide. Okay, so spring tides are bigger tides. Okay. Then another version of the spring tide is during the new moon, right there, when it's lined up in between the Earth and the sun. So we're going to get that twice a month. Then we have the neap tide, which is when the moon is either in the first quarter or third quarter phase, and so it's going to be pulling at a 90-degree angle to the Earth, and so things are going to be a bit more calm. I hope you enjoyed our lesson on eclipses and tides. This has been Mr. Holsey of H² Sufficiently Understood Science. Remember to like, share, and subscribe, and hit the bell notification to know when we post new tutorials. Until then, see you next time.